All right, so look at this one. We're going to use completing the square. It says x squared plus 8x plus 9 is equal to 0. We have a lead coefficient of 1, and we have a b term that's an even number. That makes completing the square a lot easier. So the first thing we're going to do is we're going to subtract 9 from both sides, and we wind up with x squared plus 8x equals negative 9. Now we want to take half of the middle term, which is 8, the b term. So half of that, divide by 2, and then square it. And so that's 4 squared, which is 16. So we're going to add 16 onto the left, and we're going to add 16 onto the right. On the left, it's going to become x squared plus 8x plus 16 equals negative 9 plus 16 is 7. And so now this one is going to factor. It's going to become x. Remember, it's an x, and then it's half of the middle term. So instead of plus 8, it's plus 4. That's half of plus 8. And then we square it, and that equals 7. And so now we're going to do the square root of both sides. Let me put this 7 over here so I can put the square root in. Square root, and we're going to do plus or minus. And then that's going to give us x plus 4 is equal to plus or minus the square root of 7. Now we're going to subtract 4 from both sides. And remember, we want to squeeze that in front of the plus or minus. Over here it cancels. And we get x is equal to negative 4 plus or minus the square root of 7. And the only way you can write those, this is two answers. Negative 4 plus the square root of 7. So one answer is negative 4 plus the square root of 7. The other one is x is equal to negative 4 minus the square root of 7. Those are the final answers. And these are both real numbers because there's no I. And therefore, we know the discriminant must have been positive. And we can say that there are two real solutions. Okay? All right. Let's try another one very similar to this. All right, so here's another one that's really good for completing the square. The lead coefficient is 1. The middle term is even. So let's go ahead and complete the square here. First thing we're going to do is subtract 29 from both sides. We're going to get x squared minus 10x. This cancels, is equal to negative 29. Now we're going to take half of the x term, the x to the first power, the b. We're going to take half of it. So half of negative 10 is negative 10 over 2. And we're going to square it because we take half and square it. Half of negative 10 is negative 5. And we're going to square it. Negative 5 times negative 5 is 25. So we're going to add 25 here. And we're going to add 25 here. We wind up with x squared minus 10x plus 25 is equal to negative 29 plus 25 is negative 4. And so now this can factor into x minus 5 squared. Remember, it turns into a binomial. It's x, and then it's half of the middle term here. Half of negative 10 is negative 5. And then we close the parenthesis. Then we square the whole thing. And that's now going to be equal to this negative 4 over here. Okay, negative 4. And now we're going to square root the left. We're going to square root the right. And we're going to put a plus or minus on it. When we square root the left, it cancels the square, and we have x minus 5 remaining, and that's equal to plus or minus the square root of, well, let's talk about the square root of negative 4 here. Remember that the square root of negative 4, this, we can't take the square root of a negative number. This is a complex number. Square root of 4 is 2, and because of this negative, we'll put on an I. So really, this is 2i. And so now we're going to add 5 to both sides. Add 5. Cancel over here, x is equal to, we're going to put the 5 in front of the plus or minus. We get 5 plus or minus 2i. And so now we have x is equal to 5 plus 2i, and x is equal to 5 minus 2i. X is equal to 5 plus 2i. That's one answer. The other one is x is equal to 5 minus 2i. That's the other answer. They're both complex numbers, and so we know that this has two complex solutions, and that must mean that if we had done the quadratic formula, then we would have wound up with a negative discriminant. Okay, In the next video, we're just going to do a couple more examples just to sharpen the saw.